Solving triangles. So here we go. We're going to try and find all the possible triangles. That means there might be more than one, or there might be none, or might there just be one. We'll take a look. I like to start with a sketch to make a prediction, and then follow it up with mathematics. So I have one side that's a length of 4, and right opposite it is an angle of 50 degrees. So what does that look like? Well, I've got, here is my horizontal line, and I'm going to draw 50 degrees in here. Looks more like 45, but anyway, it's pretty close, 50 degrees. And then the side opposite is going to be 4 units long. So that means this one here, right opposite is 4 centimeters. I'm not going to draw it in yet. The second side is 10. So that means that this side here is 10, or this side, this one right here. It doesn't matter which one. I'm going to choose the top one there, 10, and so this is 4, which is shorter than the 10. Now, if I can see that that's going to dangle, right? That's not going to hit the bottom of the triangle. So my prediction is that there are no triangles. But let's prove that mathematically. So if this is 4, let's pretend it could reach the bottom. And we want to find this angle. We know this is A and this is C. So let's use our sine law to set that up. So here we go. The sine of 50 degrees over 4 equals the sine of B over 10. And I'm going to multiply both sides by 10. This cancels on this side, and I end up with sine of B equals 10 times the sine of 50 degrees over 4. Entering that into my calculator, I'm going to get a number that's 1.92 equals the sine of B. Now right now I'm already suspicious because I know that the definition of sine is opposite over hypotenuse. And opposite always has to be smaller than the hypotenuse. So this fraction or this ratio is going to be less than 1. And I've got a fraction that's bigger than 1 here, 1.92. Now if I enter this into my calculator, in other words, if I want to get rid of the sine, I'm going to take the inverse sine of both sides. Your calculator should spit out an error message. Now that error message might look different from calculator to calculator, but there's a problem. It can't do this because it doesn't exist. And that confirms that this side here was way too short, so there was no triangle possible. So find all the possible triangles. There are none in this case. So let's do a bit of a prediction before we try and figure out how many triangles are possible here. We've got a horizontal line we're going to draw, and I'm going to put my angle A here and draw in 50 degrees and a distance of 18 centimeters. There we go. Now the next side, which is opposite angle A, is longer than that. It's 20 centimeters. So that means it can't go straight down. It's going to have to swing out or back. Now in order to go back, it's longer than this 18, so it's not going to fit, which means there should only be one triangle. So let's see if the mathematics tells me the same story. I'm going to use the sine law. So this angle B, sine of B over 18 equals the sine of 50 degrees over 20. Multiply both sides by 18. Cancels on the left, and I have the sine of B equals 18 sine 50 divided by 20. So that's 0.69. That's a good sign because it's less than 1. That means that a triangle is going to exist. We're going to find angle B is the inverse sine of 0.69, which is 43.5 degrees, or 43.6 degrees if I round properly. So that means angle B could be 43.6 degrees. Could I use the ambiguous case to find my second angle? So could there be an or angle B is 180 degrees minus 43.6 degrees. That's taking into account that when we solve a trig function like this, there's two possibilities, one on the first quadrant and one in the second. And so that means if I consider that second possibility, I get an answer of 136 degrees. So it could be 136.4 degrees. Is that possible? Let's make a quick sketch. If this is 50 degrees and this is 136, notice that these two already add up to more than 180, so there is no way that can work. So there's only one possible triangle, which our little sketch predicted, and now we can go from there. What is the missing angle here? You use 180 degrees and subtract 50 and 46, so angle C is 180 degrees minus 50 degrees minus 43.6, which equals 86.4 degrees. So the last thing to do is to calculate what C is. So C over the sine of 86.4 degrees equals the 20 centimeters over the sine of 50 degrees. So unclear. Multiply both sides by the sine of 86.4 and I'll get my answer. Now while I'm typing this into the calculator, maybe you can make a prediction about whether or not you think it's going to be larger than 18 or smaller than 18 centimeters, just by looking at the diagram. So sine and that equals 26.0, so it's 26.1 centimeters, and if we look at the diagram, yeah, we do expect it to be a bit bigger than the 18, so that's not a bad estimate.